which caught my attention, and I checked and Cloudflare was down. And that's bad because something like 10% of the, or 15% of the internet is now going to Cloudflare. And the way Cloudflare works is nobody goes directly to your web server at all. They go to the copy of your web page on Cloudflare. So if Cloudflare goes down, your whole site is gone. So they try to avoid that, obviously. And they were actually down for several hours. So I got a clue from a server administrator. There was getting to be a lively discussion on Twitter among people, what's going on, how long is it going to last. And one guy, it's a server connected to the backbone of the internet, started talking about how he could see the BGP routes for Cloudflare flapping. And I said, well, I know from a previous outage how to look at those. There's this cool tool called BG Play, which lets you visualize BGP updates. And the interesting thing here is, this shows you the number of routes added or withdrawn, and that is something that does not happen very often at all. For a normal, healthy website, that will just be a couple of those in a day. And Cloudflare had 4,660 of them in a space of an hour or two. That's what this graph is. So the routes started to flap here at 1:42 a.m. our time, and it wasn't over until 3:30 a.m. our time, and I noticed it was out. My website was down at 1. So even before this started happening, reachability had already gone away. But anyway, the fun thing about this is you can play it in real time, and so I made a movie of it. You can watch it happen, and I think it'll play here. We're going to see. Yeah, there it goes. All right, so this is what you're seeing here. These are AS numbers. This I talked about this before. Border Gateway Patrol does not route by IP addresses, it routes by AS number. It routes from company to company. It says, so the best route is to go through Sprint and then AT&T and then City College. That's how it thinks. It counts how many companies you're passing through, and that's all. That's how it aggregates large quantities of the internet. So these are all companies, these are routes to Cloudflare, and the big thick ones are routes being removed, I think. If you watch it, say pass change, pass change, pass change. You see up there, these are the BG updates right at the top. And you can see how much time it takes. This is still 1:52, 3 to 52nd second, one in the next second. There's like a rate of several every few seconds. Looks like about an average rate of 1 per second here. And that's these lists here. This is what BGP routes look like, just a list of AS numbers. So there is a path that goes from this company through that company and that company, and it changes. And route withdrawals, I think, are the ones that come back real. Route withdrawals are the ones that are bold because that's really suggesting something is really wrong. Anyway, so this, for an hour, Cloudflare flapped up and down, and everybody's website was down for all this time. And they analyzed it to tell us what happened, which is one good thing about Cloudflare. They really do tell you what really happened when they go down with no nonsense, and they tell you rapidly. And all this time, the CEO at 1 in the morning was on Twitter answering everybody's complaints because everybody's website is down, and they're screaming bloody murder. And I must say, the normal in this business, like my web host, is it goes down, and when you contact them, there's nobody that cares. There's never any status update. They just leave it down for a couple of days, then they turn it back on, and they don't tell you anything. Like City College doesn't. Most people just don't have anyone allocated to have any communication with the customers about this, but Cloudflare does, and then they have technical details. They explain what happened. Now, the thing about Cloudflare is they make your website faster, and they also protect you from attacks by blocking attacks. In order for this to work, they have something like 23 data centers, and they use Juniper routers because Juniper routers have the ability to quickly propagate BGP information by a special protocol just inside Juniper. And they use that, so whenever they detect an attack anywhere, they immediately propagate a defensive rule to all the other routers right away. So that's what they were doing. Somebody attacked them. This is things called FlowSpec, the thing that allows you to quickly propagate routes to all your routers inside your own company. So they got an attack, and the attack was detected as having packets that were 99,985 bytes long. And this has led to quite a bit of argument with me and other people on Twitter over the last couple of days because that is not possible. And Matthew Prince agreed with me when I said, if you just take a look at your good old friend, the IP header, you will find out that there is no possibility of that. Here's the glorious IP header. And, yes, IPv4 header, good point. Okay, here's IPv4. The total length is a 16-bit field. It cannot encode anything larger than 65,535 bytes. That's the largest possible number. And by the way, it can't deliver that in one packet. It can only deliver packets with a size up to about 1,500 bytes because that's all you can move over Ethernet. So it has to deliver them in the form of about 50 packets, which are then reassembled. But there's a fragmentation process. But the fragmentation offset is here, and if you look at the fragmentation offset, it's 3 bits shorter, and when you read up on it, it tells you it's in units of 8 bits. So the fragmentation offset also says even if you fragment something and you want to assemble it, you cannot possibly ever point to anything larger than 65,536. And so I went and looked up the ping of death, because the ping of death was a big ping, and I checked, and the ping of death was only 65,531 bytes long. That was too much. But it never exceeded 64K. You cannot possibly send any IP version 4 packet that would be ever result in anything being longer than 64K. So, and it can't do it over IPv6 either, because IPv6 doesn't allow fragmentation. So you could deliver 90 kilobytes in an IPv6 packet, but only if you send it over a network that can move that in one packet, and there's nothing you can buy at all that will do that. Not that I know of. Even Token Ring couldn't do that, and it's all obsolete. So my statement to Matthew was, this must have been a failure of their detection device, telling you this lie. It can't have been a packet that long. But anyway, they did what they always do when they get an attack. Their edge device said, I'm receiving attacks like this, so they made a rule to exclude it, and they propagated that rule out. And for some reason that has still not been made clear, this causes Juniper routers to crash and die. And it killed all their edge routers, and it took them a couple hours to figure out what was going on and stop it. And so, you know, they're considering, I think what he's talking about is in the future they're going to just roll it out to half the network and wait. Because if half of it stays up, that can pull all the traffic. But you have to, this is how you learn as time goes on. How do you quickly respond to an attack, quickly enough to stop it, and yet test your updates enough? There's a clear conflict there. Most conservative, a lot of people are screaming their normal data center administrators say, well, you should test your rules, you should be real slow about deploying the update, you should have a simulation. Yeah, you do all that under normal conditions at a data center, but not when you're fighting off attacks, which is all they do. They get hundreds of attacks all the time here. Anyway, so that's what happened, and
they mentioned.
Yeah. Oh yeah, they mentioned me, and then they've had somebody else's video. Yeah, they mentioned me, and I had a video. I was one of the first guys that was talking about it. But anyway, one thing about Cloudflare is they have good descriptions of what's wrong, although I must say they still have said nothing about an report that says that their web application firewall is worthless. Came out about 4 days ago. And I contacted my person builder and said, I really think you need to say something. But so far they just are saying nothing about it. Yeah.
Did that attack affect your website?
Yes. Not the attack, but Cloudflare's response. And my whole website was down for all this time. That's how I got my attention.
Huh.
And so, yes, everybody's website was down, but Cloudflare was down. That's one thing about the system. You have to trust them. So this is really bad for them to actually go down for a period of time, and they have to really have a complete explanation, which seemed to comfort people. But I mean, this means in America, it was a convenient time, 1 to 3 in the morning, but they've got customers in Europe and Asia and everything. There's got to be somebody for whom this was the middle of the business day, and it's not fun that the websites are down. And a bunch of them are out of bed. That's why I got up, all kinds of server administrators are out of bed. The alarms have gone off, the website is down. No network administrator got much sleep Sunday morning. They all woke up at 1 in the morning to find out why is my website down. And that's why they were glad to reach the CEO right now on Twitter, and he'll tell you it's our fault. Because that's why guys tell me on BTV updates. Then I asked him the question, he didn't answer the next day. He said, well, as soon as I found out it was Cloudflare, I just went back to bed. I said, well, I can't fix it. Fine, I'm going back to bed. Yeah.
So if clients are routed to a copy of your site on Cloudflare,
yeah,
and that's done through DNS.
Yes. And Cloudflare is your authoritative DNS.
A quick fix would be just to change DNS servers to go directly to the site while Cloudflare is trying to...
Yes, you could change your authoritative DNS server. That's true. That would be what you could do. But the problem with that is that takes time to propagate. So you wouldn't want to do it unless you were giving up on Cloudflare forever, or if you thought they'd be down for a long time. But yes, you're quite correct. You changed, yeah. You have a question over here, right? The problem was caused by that rule, which caused the Juniper routers to crash and cycle up and down. And that is, no one knows why. There was a similar vulnerability reported about 4 months ago in Juniper devices, and a patch came out, and Cloudflare said their Juniper routers were patched, and they still crashed. So apparently there's a new, unknown vulnerability in Juniper routers, which they hit. And so now you could say maybe they shouldn't all have the same brand of router, maybe they shouldn't link them all together, and that's where they have to find the balance. I mean, having them all the same and linked together makes them able to respond quickly to attacks, but it also means one mistake can take it all down. So they're considering how to fix their system. The last time this happened, they went down for 20 minutes because they added a new Asia Pacific data center, and they put out bad border gateway control updates. And rerouted all the traffic to the wrong place. And after that, they talked about ways to make border gateway patrol more resilient. And I was told by Ed Holy, who's a BGP expert, that there is a way your company can have 2 of those AS numbers. So you can have 2 different ways to get to you and change one and let the other one stay up. It's possible to have redundant border gateway patrol, although I don't think they have that yet. But that is one possibility. Otherwise, every time you change BGP, you're gambling the whole company. But most people almost never change this stuff. I mean, you set it up right, you leave it like City College, probably haven't tested any stuff in 20 years. You set it up once, you're fine. But Cloudflare is the company that has to constantly change their internal structure to cope with every attack. It's automated outsourced security. There's a question over here, right? Yeah.
About the time to the cache of the DNS, why is liquid like 1 hour? What is the advantage of not having something smaller? Because you're probably not going to use the same website during 1 hour.
Yeah, I know. Some people now put 5 minutes. Some people put 24 hours. This is a question of how long you should remember DNS settings before asking for a refresh from the authoritative DNS server. It's a good question, and I don't know the answer. I know in practice, a lot they call it quick refresh DNS or quick flash DNS or something. It's DNS updates a lot faster in most cases now. But DNS is fantastically inefficient. In the IP version 6 class, this really comes up because students have to make a lot of DNS updates. And if you watched, there's a tool where you can just watch the DNS updates propagate around the world, and you will just cry. If I have a class of 10 students, they all come to a step where they change their DNS. For 8 of them, it updates in 5 minutes. For 2 of them, it takes 2 days and maybe never. It is really an inefficient, ineffective system. I don't know what's so wrong with it, but when you update DNS, you then can roll the dice to see if your result is actually going to do what it's supposed to do or just get stuck somewhere. And then, if you get frustrated and change it again, you can end up having multiple waves of contradictory information, each imperfectly propagating around the world, creating where your flight comes up, your site goes down, your site comes up, your site comes down. That's what happened at City College for the first 2 weeks of class this semester. We had a defective DNS setting, and it just caused everybody's access to the site to randomly flag up and down. All right.
Is WPA going to be broken?
No, not really. That's why nothing really wrong with WPA. I sort of frustrated my CISSP class because I gave them a list of about 20 things and said, how many of these things are too unsafe to use? And the only things that are common use that are really too unsafe to use are things that send passwords in the clear, like WPA is not too unsafe to use. There are huge troubling things about it, but there isn't any tool to hack into your WPA. If nobody can guess your passphrase, they're not getting in. However, WPA2 is better. But you don't need to give management a hard time about what they're using unless it's really broken. If it's just not the best option, that's not necessarily a reason to make a big deal out of it. Well, WPA2 is stronger, but WPA remains unbroken. People are nervous about it, and they're afraid it would get broken because of an attack that came out about 4 years ago, but that attack did not lead to a break. There is a small defect in WPA. There are times in which you can actually inject packets and they'll be accepted for a few minutes at a time. And that's not right, but that in itself is not enough to break it. They'd have to have several other defects appear to break it, and they have not appeared.
But it grants access if you inject a packet?
It lets you force it to repeat some packets back to you encrypted. So it gives you information which, if it was web, you could have used to find the key. But it turns out that the math is good enough that that has not turned into a successful attack. But it made people nervous. That's why people recommend going to WPA2, because WPA might be broken. But it's not broken yet, as far as anybody knows. And so what's weak about MAC filtering? You can just run Wireshark and get somebody else's MAC address. If the MAC addresses were like passwords or like WPA keys, then that wouldn't be a weakness. Because if you had the key, you'd get on, but there's no way to get the key. Yeah?
Is MAC spoofing possible from outside of the network?
Well, MAC spoofing is in principle possible at any time. The question is, how do you get the MAC address? And you would have to find some way to get it, and the only easy way to get it is if someone's using the network. And then if you're anywhere within line of sight of the network, you can get it. And line of sight depends on how good your antenna is. At DEF CON a couple of years ago, they got pickup trucks and put 6-foot radio dishes on them, and they sent 802.11 over 50 miles from one mountain to another. So if you could have a pickup truck on Twin Peaks with a big antenna and be getting the web keys from there. Wow. So you don't have to get anywhere near your company or anything. Yeah?
About big trucks stealing web keys, doesn't the target network has to have a strong signal too, so it can reach?
Yes, so if you wanted to connect from far away, you would have to you have to transmit packets to the same big antenna. With a big enough antenna, you can have a strong radio signal and connect from miles away. I mean, but
So let's
not,
say someone with a big antenna with my wireless hood at home. would not
they could
be
do
good.
it. No, they could receive and transmit into it, yes. A directional antenna from far away with enough power, yeah. You could send it from another galaxy and you can do it. It's,
Like, my question is my hood going to reach them?
yes,
Yeah.
because some port, it's very weak, but they're going to receive that weak signal and amplify it. So, I mean, in principle, you can send radio as far as you want if you have enough power. But it gets down, you know, like megawatts and the stations to go across the earth. But yeah, I mean, that's the thing. That's why people were nervous about using radio. You really want it encrypted because you really, in principle, it goes forever, like light. You know, you can pick it up light years away in principle if you had a powerful enough antenna. All right, any other questions? Those are all good points. So let's talk about change management here. So we got down to this stuff. So when you're going to make a change on your network, like for example Cloudflare, right? They wanted to change a rule to block an attack, and they didn't go through any process of testing it first, because it's impossible when you're trying to stop an attack in progress like they do. But normally, you're not in a panic mode like that, and so this is why corporations get irritated. I don't have the right word processor, I want a different one, they won't let me just install it, I don't have administrator rights, I have to ask for permission and wait 2 weeks, and then management will say, no, just use the one you've got most of the time. At big companies, because that's what you make, that's how you control your network and make it reliable at big companies, by not letting people do all sorts of different things all over the place. But anyway, if you do let changes happen, and of course some changes are ultimately necessary, you have to replace computers, you have to open new buildings and fill them up and change the routers and stuff. So you have to have a system whereby you record everything. And one thing about that Cloudflare outage is they do have a record of everything, right? When something went wrong, they were able to say, this is exactly what we did. So at least you should be recording everything that happens. And that's you documenting your changes. So you don't want administrators just doing something on the fly without telling anybody, without getting permission. This is what happens at small companies, right? The network's down, fix it, fix the server. I don't know what he did, he fixed it, it's better now. This is fine as long as you have just one person, and you depend on that one person's mind to control your network. But when you get larger than that, it's not good enough. You have a team of people, this guy's on vacation, the network is down, what are you going to do, bring in a consultant to fix the network? Whatever you do better be written down. So once you get a little bigger and more formal, then you have to propose a change, get approval for the change. Now simple changes can be approved quickly, and of course in emergencies, all procedures usually thrown out the window, like the web server is down, just do anything, and we'll talk about later what you did. But normally you have some kind of formal change review board for something, like at the college. We rolled out, we used to have older computers here, and about 3 or 4 years ago we rolled out a new Windows XP machines to all the staff at the whole college. And it took a whole semester, and they did it right. They warned everybody, they had meetings to tell you how to use the new system, they put it in like one department first, and then another department next, rolling over a course of months through the whole institution, so people had time to adapt. They told you like when they were going to come take your old computer, when they were going to put in the new one, so everybody could make sure they're ready and all that jazz. It really is quite a job if you do a thing like that. So, all right, that's the process there. So now protecting your data, there are 2 different considerations here. One is to make sure the data remains available. That's high availability. But here they're talking about keeping your confidential data, not leaking out credit card numbers and other secret information. If you do leak these out, then your customers get hurt. You have to admit it, in California anyway. Not every state requires you to admit it, but California does, and I think 20 or 30 states now have laws requiring you to tell people if you lose their data, which is a very good idea. If there weren't laws like that, you would never know about most incidents that happen. And then, of course, people may hate you, although it's amazing how little they hate TJ Maxx. It just rolls right ahead. They lost everybody's data, and nobody hates them for it, which, by the way, is something I often see. The real reaction of the supposedly ignorant people makes more sense than the experts, because TJ Maxx is not the only company that got hacked. Every major retailer got hacked, all 30 of them, Sears and everything, at the same time, but the rest of them managed to keep their name out of the paper. So, and besides, I'm probably, another thing is a company that actually had a major data breach is forced to improve their security. You're probably safer using your credit card at TJ Maxx now than you are going to a random retailer. That's why I'm using Sophos antivirus. They had a huge exposure of major flaws, and they patched them. The other ones haven't been tested. So, anyway, you can argue. But anyway, there's also maybe regulatory fines and lawsuits, and I think there was a big class action lawsuit against TJ Maxx. So, data at rest is data that's stored someplace. This is one category. You must protect this, usually with encryption. but possibly just by physically logging up the devices. Data in motion is traveling over a network. So there are different concerns here. And I think the PCI compliance requires you to protect data in both cases, but it's pretty vague about what you have to do. And this is why, at least until 2012, web encryption was sufficient to meet PCI compliance because technically it encrypted the data in motion. It used terrible encryption that anyone could crack, but all the rules said was it must be encrypted. So this is the kind of stuff that happens. Anyway, data loss prevention is if you have something on your network watching what's leaving your network and noticing whether it's confidential. It would therefore be nice to label all your confidential documents with some kind of mark that you've been caught leaving. That would be the easiest way to do it. If you don't do that, you're going to have to just look for things that are suspicious, like social security number, looking patterns of numbers or something leaving your network. Google did very well at this. Google is the only company I know that ever had a big victory here. They totally caught the Chinese stealing their data. They saw suspicious data leaving their network and tracked it down to find out who did it, which is pretty awesome. Everybody else that got hacked at that time did not succeed in noticing the Chinese stealing their data because they're relatively sneaky about it, but Google was able to. Now, if you encrypt traffic, it's essentially impossible to do data loss prevention because you don't even know what anybody's sending, and this is why big companies usually do not let you use any encrypted protocols. And if they do, they will break them in the middle. You'll try to connect to Gmail, they will decrypt it in the middle, invalidate the certificate, read it, and then re-encrypt it to send back out again. That means your certificate will be invalid unless they put their certificate authority in your browser, or unless they buy a root certificate authority from a crooked certificate authority, so they can impersonate the certificate authority. That's been the open secret that came out because of TrustWave about 9 months ago, admitting that they do routinely sell those. And they're going to quit, and all the other certificate authorities are still selling them, supposedly. This has not been proven, but I think it's one of the open secrets, like it's been an open secret for 5 years that it's China hacking everybody. The other open secret is the certificate authorities just sell you root certificates to anybody with money. So everybody can just impersonate them, so your HTTPS traffic, in fact, is not really encrypted to the endpoint. It's encrypted to anybody with money between you and the endpoint that felt like paying for that certificate, which is not what was supposed to happen. But that's what happens with math. Your math is beautiful, but the humans can do a crooked thing with it. And then, without breaking the math, you've still broken the point. Anyway, so that was the Google attack that they caught with their data loss prevention. So there's different kinds of categories. Data in use is data in RAM. Now, almost nobody encrypts data in use. There has been discussions of encrypting RAM. This comes back every now and then. People talk about it. I've never seen anybody do it yet. So while you're actually using data, it's in clear text, and therefore things that put it on the hard drive, like the page file and the hibernation file, are making plain text copies. Unless you encrypt the whole hard drive with something like BitLogger, which is why in the old days, maybe 10 years ago, you talked about using EFS encryption. You'd encrypt your My Documents folder, put the documents in there and say, there, it's safe. But while they're open, they're in plain text in RAM, and there's a temporary file in your temporary folder in your profile, and then it's going in the page file, and it's going in the hibernation file, and really, there are fragments of that are all over the bloody drive. So Microsoft finally wised up and said, you got to encrypt the whole hard drive, or you haven't really protected the data. Yeah?
About applications being responsible for protecting data in use, that is not really is what, like, one common method of decrypting thing. Let's say a program, you just open it, and after it decrypts itself, you just dump it.
Well, that's true. If someone, and that's why there are viruses and stuff that attack RAM. If someone can get a copy of your RAM, you're in deep trouble, and there's almost nothing will protect you from that. But unless they get root permissions on your box, you usually can't steal the RAM. The problem is your laptop. If they steal your whole laptop at the airport, and it's still turned on, then they can get the RAM. Yeah.
If you encrypt the whole RAM, and there is a virus in your RAM.
Well, if you encrypt the RAM, then it'll slow down your machine. Your processor will decrypt it all the time. People have made the hardware and started bragging about how they're going to switch to encrypting all RAM. It's just not out there yet.
So if it's encrypted and you have a virus running in your RAM, will your antivirus be able to detect it?
That's a very good question, and I don't know the answer. But every process is going to have some ability to decrypt that RAM. So I don't really get quite how this is going to work. I mean, you're going to encrypt the RAM, but every process is going to be able to decrypt it, so the key must be readily available to everything. So I don't quite get how you're going to encrypt it and make it not hard to make it not easy to steal the key. And I've never seen anybody actually do this yet. Encrypting RAM is what people talk about, but I see problems. But maybe there are solutions. Anyway, so The closest thing to that is Microsoft testing the kernel every time it boots up with UEFI. That's, they check the hash of the kernel and make sure it hasn't been altered every time it boots up. That makes some sense. That's not exactly encryption, but at least it's integrity protection for the data. Anyway, NTFS permissions are, administrator full control, managers will read only and all that jazz. You can set that stuff, but that doesn't protect the data directly. All that does is prevent Microsoft operating systems from accessing the data. If you reboot the machine to Linux, it will ignore those permissions entirely. So the only thing for NTFS permissions is if you put those on a server and the server is locked in a server room you can't get to, then people that connect over the network cannot get the data if they can't break through those permissions. But if someone steals your laptop, NTFS permissions do not protect you at all. All they have to do is copy the data off the hard drive and read it with Linux, or boot from a CD or something, and they can totally read in there because those permissions don't block it. So NTFS permissions do not really protect data at rest. They protect data as long as it's being accessed through a running Windows system. All right, and we talked about folder level encryption protect files at rest but not in use because it's in RAM. And applications often have the option to encrypt data, which is nice. It helps decrease the damage it's done, but actually encrypting a database is kind of an exercise in futility as far as I can tell, because usually the way you steal data from a database is with SQL injection. So you steal it from the running database, so even if it was encrypted, you go through the application that has the authority to decrypt it. So it does mean that if you stole the hard drive from a database server, the data might be encrypted, and that might save you in that case, but that is not the normal case. You do not normally break into the room and steal the server. You normally just send commands that cause the server to just hand all the data to you, and that would require different protection than encryption. So the Trusted Platform Module is the encrypted graphic coprocessor to make a Windows machine meet military standards for security. It's a special cryptographic chip on the motherboard that handles encryption, and it also handles storing the key in a way that it's hard to steal. Joe Grand at Noisebridge did manage to steal the key off of Trusted Platform Module by destroying 100 of them by dissolving the case with acid until you could reach down with a tiny needle and touch one wire in there that actually had the key. That's pretty extreme, but it is slightly possible to do that, but in practice that's a pretty hard attack. So unless you're really planning to kill the president or something, nobody's probably going to work that hard to break through your encryption. There's also hardware security modules that encrypt on a whole network. All right, so a Trusted Platform Module has a key, can generate and store keys, and is used by BitLocker. HSM is a security device you add to a system if you want to, a mathematical coprocessor, and this might be used on a server that's handing out things like HTTPS websites to make them faster. So it lets you use these SSL accelerators to use them, and you can have various other cryptographic servers where it's worth paying for a special module just to do a lot of encryption, like certificate authorities that are just constantly generating and handing out cryptographic keys. You have special hardware at HSM added just to make them faster for that purpose. There's been a huge concern from 5 years ago that when people switched from HTTP to HTTPS, it would cost them a lot of money because people said it would be much slower. Google did it, and they said it only made their stuff 1% slower. So it turned out not to really be that huge burden on processing that people had thought it would be. Anyway, yeah?
Are CAs what you get from like VPNs?
No, certificate authorities, not usually. VPNs usually have shared secrets. Certificate authorities sell you certificates like VeriSign, and they typically charge hundreds of dollars a year. So the big companies buy them so you can connect to a browser.
And those are actually physical hard?
No, they're just mathematical numbers. You'll see them in your browser. The digital certificate, if you go to google.com.
What are you generating in a VPN? So like if you're
In a VPN,
like you say,
you just generate a random, there's two things. There's your own password and there's a session key, which is entered in usually for most of them. I mean, this is the certificate. We've seen these before. This is the identity verified.
Yes.
There's the certificate. And this is just a number that comes electronically to you. But
So it expires like...
it has an expiration date, and it's got a key. Someplace down here, here's the key. 128 bytes, there it is. That's the key. That's 128 times 8, so that's a 1024-bit key. That's it. That's what they pay hundreds of dollars to VeriSign to get. Get that public key, and for VeriSign to answer every request, guaranteeing that really is a genuine key. That's what you're paying the service for. And you don't usually run VPNs this way because it's too expensive. You usually have a shared secret key, like a password, like a WPA password that is just entered in every company laptop as they go, or it's entered in your software. Right. You can run VPNs to that, but it's not usually the most cost-effective way to run your company. So data leakage is a big issue. Data loss prevention watches on your network to see if your secret data is leaving, and that scans everything. It can look for patterns of data, or it'd be a lot nicer, it can look for the marks which your company enforces. Every document must say confidential, company use only or something, then you look for that mark. That would be handy. This is one thing that for some reason never caught on with digital rights. I don't know why the movie people don't just watermark the blasted movies with a special mark so you know what the pirated movie is. They do that with the textbooks. I have an online textbook and it's got my name in gray behind every page. So if I let somebody else use it or quote, copy and paste it, they know who spilled the beans. They know who to prosecute for copyright infringement. And somehow that technique never caught on for the movie people. Anyway, the other thing, of course, is all these USB hard drives and other portable devices. This is what caused WikiLeaks. Bradley Manning copied everything onto a CD and just took it away. These small portable devices make it very difficult to protect your data. In the first place, malicious employees doing what they shouldn't do are very hard to stop, and people will just lose the devices all over the place. So you can encrypt them anyway. BitLocker to go encrypts USB devices, and there are other products that will do that. And then at least you're saved from accidental disclosure. But normally you just order your employees not to take the data out on a USB. You don't usually search them on the way out. There's not, and the other thing you can do is you can have a group policy that forces them only to use company USBs, and those can be encrypted anyway. But as far as controlling what they take, that's really quite difficult. And in practice, it's a very leaky system, and tons of corporate data is leaking out all the time on USB devices. They've lost all over the place. And nobody has any real cure for this yet. Also on iPhones and iPads and Androids, everyone's doing company work on them, and they're not really being managed very well, and that's why there's a big issue in how to correctly incorporate these things into corporate domains. That's your mobile devices. Now what you want to do is they ought to all be encrypted. They ought to be like the company iPad that's different than your personal iPad, and then you can turn on remote wipe and force them to have a long passcode and all that jazz. But in practice, most everybody uses their home device because they love it. They do company work on it, and companies don't really control their security very well. It's a problem. And there's plenty of products available to track and remotely wipe these devices. The problem is, when people lose devices, you often do not get to remotely wipe them. For example, if people lose their cell phones, probably some significant portion of cell phones are actually gone. They actually fell in the trash or in the street and got broken, and so you will never hear from that phone again, so you never get to send a remote wipe. So you can't reassure your customers by saying, there was a copy of the data, but we wiped every phone, so we know it's gone. They said, well, no, some of those phones vanished and we never got to wipe them. So you cannot say that you know what happened to the data. And by the way, even if you did wipe it, you have no way to know it wasn't copied to another device before you wiped it. So this remote wipe thing is not really making you very happy as a data prevention measure. Encryption is a lot better. Anyway, so cloud computing is the big thing, like Cloudflare. But Gmail is another one. So there's different ways to do it. Software as a service, infrastructure as a service, and platform as a service are three common ones. This is where you do use somebody else's computer to do your work for you. So, all right, Gmail and Google Docs are software as a service. This means they have already installed a program and an operating system somewhere, and all you do is make an account and use the options they give you. You cannot write your own software, you can't install your own operating system. There's Gmail. You can send Gmail, but if you want Gmail to have some other feature, tough. You have to ask them to please add it. You can't change the code. You're just using a system that somebody else has provided for you. The only problem here is the data you added is now up there, and this is a concern for a lot of people that are worried about Google Documents. Google got kind of a scandal about this because there's an official federal security restriction required for the thing they use to put up documents and spreadsheets, and Google claimed to have it when they didn't. Microsoft Office really has it, and Microsoft went to town with that. Google lied to get it, because Google is not eligible to bid for federal contracts until they meet the security requirement, and they didn't meet it at a certain time, and then they claimed they had, and so Microsoft got really mad at them and said, you can't even, you guys have to buy Office and they can't use your sleazy product that's not ready to be secure enough. So infrastructure as a service is where you rent a server somewhere else. I do this, I have a Zen virtual machine, for example, and they give me a whole virtual machine and I can do anything I want. Install any operating system, put on any programs, do whatever I want. Although when I made a Tor exit note on it, and I got a bunch of DMCA takedown notices, they said, well, you can't do that. And I can't really blame them for that. That was kind of rude. But anyway, this way you have complete freedom to do anything you want with the machine. They just give you so much hard disk, so much bandwidth, so much processor time, and you can do whatever you want. And platform as a service is where you get a whole platform with an easy to configure operating system on it, and you get more. You get virtual routers and virtual switches. That's Amazon. in Amazon, you can put up a server, and when you want, you can clone the server and have more servers to handle more traffic, and you can divide them into subnets and make them fail over and back them up, and all sorts of fancy stuff. They give you basically a whole data center worth of equipment that you can rent as much as you need of, and this is why a huge portion of the web is just at Amazon. It is so much better if you have some great idea to just use an Amazon virtual machine to put it on than to go buy a server and an internet connection and try to keep it up and worry about the power and the cooling and all that hogwash, when it's just you and your friend writing a game, and you want to make your game awesome, and you don't want to bother with all that. For $30 a month or something, you get an Amazon virtual machine that will service your first 1,000 or 2,000 customers until you get money rolling in, and then you can just keep renting more and more machines from Amazon forever. It's hard to say no, and almost nobody does. Almost nobody owns their own stuff anymore for small companies. Anyway, so here's some of the Amazon stuff. I think you got some projects we play with these. Amazon will give you Amazon Linux, which is Red Hat. And there's Red Hat Enterprise also, SUSE Linux. You can have Ubuntu, have anything you want. Although I think you can't get Windows in Amazon without paying for it, but I'm not sure you might be able to. So the problem with cloud computing is now you don't know where your data is. You don't know what they're doing with it. You don't know how it's backed up. You don't know whether they're encrypting the backups or losing them. You don't really know if they're leaking the data and having it leaked to other people's machines. That happened to Amazon. When Amazon first came out, somebody rented a virtual machine and ran a forensic tool and found that the previous customer's data was still on there. So how do you know that's not happening? Well, you don't have any way to know. You can't send auditors to Amazon to examine their documents. They won't let you in. Maybe they'd let the federal government in. But that's the question. And the other thing, of course, is if anybody comes to them with a search warrant or a court order or something, Amazon will just hand it over to them, and you will never even know what happened in most cases. So that's why a lot of people, for privacy and such, prefer to run their own email server and such. If you're something like a political rebel and you expect the government to come after you with subpoenas, then you would rather not use these cloud services where the government can totally get out all this stuff. And Dropbox also forgot to enforce passwords for 5 hours. They put an update to the system that just terminated the password checking, so everybody could get in everybody else's Dropbox for 5 hours. So that kind of thing could happen to anybody. Kind of feel like that. So the taxi cab has a warning. So what kind of data is at risk here? They are not kidding either. They will read your credit card number over ham radio. All right, that's data in motion. They would transmit your data in an insecure way, which, by the way, is a sin and a shame, because if they used a cell phone, it would be encrypted. Cell phones are encrypted with 64 bits or longer of the private key encryption. It's perfectly fine. Using a ham radio is just rude. Right? A technical corrective control for loss of confidential data on an iPhone. And that's remote wipe is the corrective control. After the bad thing happened, this attempts to limit the harm. So you remotely wipe it, and then you have some hope that you have somehow decreased the amount of damage done by the iPhone being stolen. Encryption would be preventive. And by the way, none of these encryptions actually work on an iPhone either. All right, what's the best way to prevent data loss from laptops getting stolen? All right, it's BitLocker, which, by the way, is now included in all versions of Windows 8, which is nice. It's only in the really expensive versions of Windows 7. All right, which of these is an encryption device added to a network? Hardware security module. Yep, most popular answer is correct. All right, CCSF uses Moodle. So what is Moodle? All right, as you know, Moodle is software as a service. You're using somebody else's, you have an account, there's only so many options, you don't get to change the operating system or anything, you know. It's like Gmail. It provides you whatever services the Moodle designer felt like giving you. You don't get a whole computer under your 100% control, you just get some service from that computer. So IP version 4 addresses are 32 bits long. You write it as 4 base 10 numbers. So each one of these is 8 bits, and that's how you get 32 bits. So the only allowed numbers are from 0 to 255. And you got a network portion and a host portion. The network portion identifies the physical location of the network, so the internet can route packets to it, and the host portion identifies the specific device on the network. So some part of this on the left determines the network, and the rest of it, which is always the right part, determines the host. So for Class A addresses, like 1, 2, 3, 4, the network is number 1, and all the rest of this determines the specific device in that network. So only the very large, oldest companies like IBM and Sun have the Class A addresses. So the Class A addresses have been gone for a long time. Class B addresses have also been gone for a long time, but City College got one of them. Now the only thing anybody can get is Class C addresses, pretty much, or used addresses sold by another company, which is what we're trying to do with ours. But Class B gives you 2 bytes for the network and 2 bytes for the host, and Class C gives you 3 bytes for the network and 1 byte for the host. So you can only have a maximum of 254 devices because you can't use all zeros or all ones in either the network portion or the host portion. So the first octet determines the class. This is the system that was used on the internet until I think 1993. The first byte would determine the class. And this 127 perhaps shouldn't be included here because that's loopback. It doesn't actually go anywhere. 10 is also reserved. But anyway, the first octet is below 127, that's class A. From 129 to 191 is class B. 192 to 223 is class C. And above that, unfortunately, are classes D and E, which were actually never used for anything for all practical purposes. And just ended up being wasted, which is kind of a shame. D is used, just a couple addresses in D are used by Cisco routers to exchange routing information, but not by anybody to deliver web pages or anything. So 147, 144 is 01, 147, 144 is the network, 01 is the host. So, what class is that in? And I'll start the iClicker thing, there you go. Okay. All right, that's class A, 99 is just a low number, so it is A, which is C. All right, good. The most popular answer is correct. Looks like some people hit A for class A, but it's worth understanding how these are the iClicker buttons. Those are what they mean. They're going to be kind of randomized. This is part of my highly advanced quiz system here. So, all right. How about this one? 222. That is a class C, so it's B. There we are, good, everyone knows it. That's what I thought. Do one more. All right, that's also class C, so it's a B. There we go. By the way, it's okay that that's a 255. You're allowed to have a 255 as long as not the entire network portion or the entire host portion is all ones. So that's not all ones there, but all ones there. That's okay. Let me try the next one, which is usable addresses. So the way it works is, if you have a slash notation, this is what took over after 1993. You no longer determine the size of a network by the value of the first byte. You can split any network up into any size you want. This is to handle running out of IP version 4 addresses, which has been a big problem for 20 years. So now you put a slash number here, and the number here determines the number of bits in network portions. So if there's 8 bits in a network portion, that means the first byte is the network, and the other bytes are the host. So this is class A. So the class A means, now if you put that IP 1, 2, 3, 4 in binary, it's 1, 2, 3, 4. If you put the subnet mask in binary, which is 255.0.0.0, it's all ones here and all zeros there. And every subnet mask is always ones on the left and zeros on the right. The only thing that changes is where the border is, and that's what the slash number is. The slash number is the number of ones in the subnet mask. So this is 255.0.0.0. So what you do is you AND it with the subnet mask in binary, and you get the network address. The network address is 1000 because it contains the network portion and sets all the host bits to 0. Remember I said you cannot use the address where all the host bits are 0 or all the host bits are 1. The reason you can't use the one where the host bits are all 0 is because it's the network address. It's not assigned to a device. It's used in the routing table to refer to the whole network, reserved for that purpose. So that's how you get the network address. So you take the node's IP address and set all the host bits to 0. So if the IP is 1, 2, 3, 4, and subnet mask is here, that means the left 8 bits are network and the rest are hosts, so you keep the network bits and set all the rest to 0. That's what's called the network address. That defines the network as a whole. Now the other end is the broadcast address. If you put all the host bits to 1, you get the broadcast address. These are the 2 addresses that are wasted. You cannot assign them to devices like printers and servers. The network address is where all the host bits are 0, and the broadcast address is where all the host bits are 1. 1, 255, 255, 255. Those are addresses are used for special purposes. You can't put them on devices. So you call all the ones in between usable. So this 1, 2, 3, 4 network is, the network address is 1000. The subnet mask is 255.0.0.0. The broadcast address is 1, 255, 255, 255. So the usable addresses go from 1001 to 1, 255, 255, 254. And that's 16 million and change. That's how many that is. It's 2 to the 24 minus 2. That's for class A's. For a class B, you call it a /16 because there are 16 bits in the subnet mask, which means the left 2 bytes are for the network and the right 2 bytes are for the host. So the network address of this 147.144 is 147.144.0.0. And the broadcast address is 147.144.255.255 because you leave the network part alone. If you change anything in the network part, you go into a different network. But at the host part, you can change all you want. The lowest host address is the network address, and the highest one is the broadcast address. And the ones in between are the usable ones. So here's how it looks in base 10. There's the address of our web server, 147.144.112/16. There's the subnet mask, the network address here, and the broadcast address. And here's the ones you can use, from 01 to 255.254. 65,536 minus 2. And class C is the same story, 192.168.110/24. This is 192.168.110. If it's a /24, there are 24 bits in the subnet mask, and the rest are 0. So you keep the first 24 bits in the address, and change all the rest to 0 to get the network address, and change them to 1 to get the broadcast address. And so those are in base 10, 192.168. It's jumped around on me here. All right, yeah, they're up there. So it's 192.168.10, and the broadcast is 192.168.1.255, so the ones you can use go from 1 to 254. Okay? You see if you got it? What's that?
Possible to have like a /22?
Yes, and we'll get there. You can have a /22 and a /7 and /18, all the ones in between, but these are the ones you start with. Exactly. And we'll get there. But that's when everyone starts getting real upset if you go there too fast.
Yeah.
That's why people whine a lot in Cisco classes and suffer a lot, because you have to really understand these before you understand those. So what is the last usable address on that network? All right, that's a class A, so it's 5.255.255.254. Good, a popular answer. That's the last usable address, because the one above it is the broadcast address. All right, how about this one? What is the first usable address in that network? All right. It's, how many bytes do I keep? 16 bits, 2 bytes. So I keep the 169.254, and then I have 01. So it's right here, it's B. The lowest number you can use. Good, a popular answer, glad to see it. How about this one? The last usable address on that network. All right, the last usable address is this one, 192.168.1.254, because the /24 means you have to keep this part unchanged, or you're going to a different network. So you take this as high as you can take it, and that's 254, because 255 is broadcast. So it's that one, that's B. Good, I see almost everybody getting it. What's the broadcast address here? That's the last one. All right, so it's, you keep 16 bits, so you keep that much and change all the rest to 1. So it's 170.16.255.255. Good, almost unanimous. Glad to see it.